happy spring. Today I'm going to talk about validity, reliability, and fairness in assessment. These topics are important because they're part of Iowa's expectations for all teacher education preparation programs, and also because we seek to unlock the potential in everyone, filling a need for high-quality teachers and educators in Iowa and beyond. And we care about this topic because it can be easy to violate principles of validity, reliability, and fairness. For example, as I think about spring, about the upcoming planting season, I'm reminded about the saying, "The rain follows the plow." Here's a quote from Charles Wilbur. He says, "Godspeed the plow. By this wondrous provision, which is only man's mastery over nature, the clouds are dispensing copious rains. The plow is the instrument which separates civilization from savagery and converts a desert into a farm or garden. To be more concise, rain follows the plow." This was the notion that tilling and other human agricultural activities would permanently increase the rainfall in a region, thus turning otherwise unsuitable dry land into land that would perform well as farmland. It was promoted in the 1870s to justify settlement of the Great Plains. Now, Wilbur was not the only person who promoted this theory. There were others who pushed the theory, such as geographers, the governor of Colorado, faculty members like Samuel Augie from University of Nebraska. And those who promoted it often pointed to the data they had collected that they believed showed a relationship between initial cultivation of land for agriculture and an increase in rain in that same area. So did this theory fall out? Did this theory work? Was this an accurate theory? As you can see from this picture, there was tremendous dust storms across the region in the 1930s, and in fact, plowing made things much worse. Instead of releasing more moisture into the air, the plowing actually lifted up the dust, which was then ready to be blown around in these tremendous dust storms throughout the 30s. Here's a picture of my home state, South Dakota, in 1936, showing the devastation of the Dust Bowl across the Great Plains. So clearly this theory that the rain would follow the plow was faulty. They did have data to support the theory, but their interpretation was quite incorrect. They kind of got into that correlation is causation fallacy, and in fact, as more settlers just happened to moving into the region just happened to coincide with a wetter period in that region. So could they have avoided this error with a more rigorous scientific analysis? Maybe. Maybe not. That's an interesting discussion for a history class. But today we're more interested in the lesson it has for us on the importance of using principles of validity, reliability, and fairness when we examine and use data to make important decisions. I'll discuss each of these three ideas and concepts and examine how they apply to assessment in our educator preparation programs. So I'll be basing my discussion, at least some of my discussion today, on the educational and psychological standards for testing. This is a fantastic resource for those who are interested in reading more. It's authored jointly by the AERA, APA, and NCME. The picture here is from the 2014 edition. An updated version is underway. I'm not sure when it'll come out, but I know the committee started working in 2024, so hopefully we'll see one soon. First, we're going to talk about reliability. Reliability, this is the consistency of scores across replications of a testing procedure. Now, reliability is necessary but not sufficient for validity. And the reason for this is because scores can be consistently good or consistently bad. So for example, I could have a car that never starts. That'd be considered reliable though because its behavior is consistent. On the other hand, if let's say my wife were able to start it by consistently using some kind of special twist on the key, and I couldn't start it, then that would not be reliable because the difference in who was swearing at the car, say, produced different results. So reliability is necessary, but not sufficient, not enough in order to have validity. So we'll talk about validity in a little bit. So here's some common issues in reliability. The first common issue is what we call test-retest reliability. Now, a test or an assessment is considered test-retest reliable if a student takes a test and then you use one of those Men in Black magic eraser tools to erase their memory of having taken the test. And then they take it again, and they get the same or very similar score on their second try. Now, what to do to support test-retest reliability? There's a lot of things you can do. First, you can try to avoid items where students can guess them correctly. You can also have try to avoid items that are intentionally tricky or deceptive that would be confusing or not really answerable accurately by someone who has the knowledge that they should need to answer that question. Try to avoid items that are confusing, lack directions, use unusual formats, are complicated themselves rather than the content itself to answer them. And try to avoid items that are prone to multiple interpretations, like football field versus a football field, which might be considered more of a soccer field rather than a football field, which are, as you know, different dimensions. The second issue in reliability, this is called multiple forms reliability. And this is if you have multiple forms of an assessment. Sometimes you do this to reduce cheating or have different sections that have different versions of an assessment. Now, it can be difficult to ensure the forms have equivalent difficulty. So to be sure that one section of the class doesn't get a really hard test, another section gets a really easy version of the test. So there's some things you can do. One of the things you can do is, instead of creating completely different forms, you can shuffle the response options if you're using multiple choice, for example, or reorder the items to make it more difficult to cheat on a test while keeping equivalent difficulty of items. You can also compare difficulty across forms by examining item difficulty using basic item difficulty tools in Icon or through some basic computations in Excel. Or you can use things in Icon to even create items on the fly that have maybe a different prompt but a similar response process required to answer them correctly. The third issue in reliability is test conditions. So for example, let's say we have two different groups taking a test on chemistry. The first group takes the quiz or the test in an English classroom with nothing on the walls. The second group takes the chemistry quiz in a classroom that's a chemistry classroom that has a periodic table on the wall. And as you would expect, let's say group B scores much better because they could use the periodic table that's on the wall to answer some of the questions on the chemistry quiz. So in this case, the test is not reliable because the settings in which the test occurred were not the same and gave one group a big advantage on the quiz in comparison to the other group. So thinking about this online quizzes or exams, do all students have access to a laptop or desktop, or are some students trying to take a quiz while squinting at their phone? So thinking about the conditions in which the test occurs is also an important issue for reliability. Trying to ensure they're equal for all the students is similar for all of the different ways in which a student might complete the assessment. The fourth issue in reliability is about grading fatigue. This is recognizing that you're only human, even though you may feel like a superhuman sometimes when you're teaching or grading students. And important to remember that as you grade, you do get tired and do not always produce fair scores across all the students, especially if you have a large class. Or your scores might drift over time, and the order in which the papers you score them makes a difference, where you might be, say, more lenient on the early versions of the paper and more difficult as you get through the stack. So some things you can do to avoid this reliability issue is to use a rubric, so you have a very standard, common way of scoring across all of the papers to make sure that you're scoring consistently. Have what you call anchor papers, which are papers at different levels of difficulty that you can refer back to. So you might have a high quality paper, an average paper, and a below average paper that you can kind of use to anchor the other responses to see if they're similar to those categories. You can return to earlier graded items to be sure you're being reliable across your scores, so go back to earlier ones and look at them again and see if you're scoring later ones in the same way. You can consider using a second grader, if possible, to spot check a few of your grades, or shuffle the order to make sure you're not always grading them, say, in alphabetical order, which would disadvantage some students versus others. And fifth, the final issue of reliability we're going to talk about today is multiple raters. Now, ideally, the grade a student receives on an assessment shouldn't be associated with the rater to whom their assignment was assigned. So you don't want some graders to be strict and others to be lenient. You want them to all have similar expectations for performance on the assessment. So some things you can do is to train graders to align their expectations to make sure they're all looking for the same thing and have similar expectations for how they're going to score those assessments. You could also, again, use a scoring guide or a rubric to be clear about expectations and how much to deduct for various errors on the assessment. And then also important as you go to compare raters to each other, having some papers maybe double scored to see if they're scoring them in similar ways, perform quality checks, or even remove or retrain graders if they can't provide reliable scores. You should also calculate inter-rater reliability statistics for those double scored exams or items to be sure that you are seeing some high levels of inter-rater reliability. So reliability is really, again, important for validity, but it's also really just the starting point for validity, because if you can't get things that are reliable, then you can't even get close to approaching validity. So once you've established good processes for supporting reliability, then you start to think about issues of validity. Validity is really at the degree to which evidence and theory support the interpretations of test scores for proposed uses of tests. Now, what's important about this definition is that it's the use of the scores that are said to be valid, not the scores themselves. So as an example, using ACT scores as an element in determining college admissions might be reasonably supported by evidence, and therefore might be considered a valid use of scores. But using those same ACT scores as an element in determining membership in, say, the Hawkeye Marching Band may not be supported by any evidence and therefore would not be considered valid use of the scores. They both use ACT scores, but one has evidence to support the validity of that use, and the other does not. So we have to be aware as we're thinking about how to use assessment scores and test scores, how they're going to be used, and then gather evidence to support that proposed use. And importantly, the higher the stakes for the decision that's going to be made using those scores, the stronger evidence is required to support that use. So to continue with the ACT example for a bit, ACT scores are often used as a factor in awarding scholarships, for example. Is this a valid use of ACT scores? And if it is, what evidence do we have to support this interpretation? So another kind of thing to kind of get you thinking about some of the issues of validity and some of the issues around ACT scores and other test scores, how we use them, how we might think about whether or not there's evidence to support that particular use. So there are lots of different sources of validity evidence. So the first is to start with the content of the assessment, how it's constructed, what's the material that's included in that. The next is to think about how do students respond to that assessment, what's the process they use to generate an answer. You can also look at the factor structure of an instrument calculated after you complete it to see how the different items align with each other. And then also another way to look at evidence for of validity is to look at the relationship with scores to other variables, such as students who score better on a teaching assessment should be expected to perform better when teaching than those with a lower score on that same assessment. And it's also important to consider the intended and unintended consequences of an assessment. For example, is it a high-stakes assessment that might prevent someone from getting a license? Or is it just a daily reading quiz? We would not expect similar validity evidence for both of those two assessments. So a first issue in validity is to think about the selection of the instrument. So the important thing is to think about that we don't just select an assessment because it's available or because other places are using it. It has to align with our goals for the program and what we want to assess in our program and what we want to know about what students know and can do. So for example, somebody might note that the bar exam, the license for attorney, the exam that's required for licensure for attorneys, is a high quality test with a strong research base. It's available in our community and it's tested under rigorous, consistent conditions. So they might suggest, well, that should be used as a graduation exam for all students, even those who are not attending law school. Now, even though the bar exam is a well-researched, highly developed exam, it's not been validated for college graduations, not designed with that purpose in mind. So that would not be a valid selection of an assessment to serve that particular purpose. So to address this issue, there should be careful examination of what you want to assess, how the scores are to be used, and the critical aspects of thinking about what the consequences would be of use of those scores in that manner. The second issue in validity is to think about how you set a cut score. Sometimes assessments are used to limit access to resources or opportunities, such as admittance to student teaching, to a practicum placement, or to a program or course that has a limited number of seats. So sometimes it's convenient to have students take an assessment and then just order them by their score, and then admit students using those scores until the seats are full. But that's not really a valid use of assessment because the difference between admitted and not admitted is arbitrary. It's set based on just a difference between one or two items typically and how those scores work. Instead, when you set a cut score, you need to use a systematic standard setting process that sets that score required for an assessment. There's many well-established ways to do that. The Angoff procedure, for example, is a common one. But if you're in the situation of where you have more qualified students than openings in a program, you can find more openings. But if that's truly not possible, then you can use some other fair way, such as a lottery, to distribute those opportunities amongst the students who are all qualified to participate in that program. A third issue in validity is low-effort assessment situations. This is another common issue with validity where students are asked to complete an assessment that has low stakes or no benefit for them from the assessment. And this results, as you might expect, in many students not putting forth their best effort. Therefore, interpretations of the scores that result from such low-effort assessments cannot be supported as valid. So to address this, you might do things like ensure required assessments provide a benefit to students. Maybe they're required as part of their grade in a course, that they have other importance to the students for their own learning and development, not just because some external group wants them to take this assessment. A fourth issue in validity is to think about how you compare scores. You have to be really careful when you're comparing scores between groups or between students. So comparing scores between two students can be a validity issue when conclusions are drawn that go beyond what's supported by the evidence. So for example, it can be tempting to say that one student knows more or is more capable than another student, even when their differences in a score is within the standard area of measurement, and suggesting that difference might only be due to chance instead of actually being a real meaningful difference between those two students. Comparing scores between programs or institutions can also be a validity issue if the assessments are given in different contexts, such as if one place has it as a required score, the other place has it as a low-stakes setting, or if those programs serve different populations of students and offer a different curriculum, Those differences could very well explain the score variation rather than differences in students' ability or capacity in that area. A fifth issue in validity is to think about the unintended consequences. It's really important to watch for unintended consequences of assessments. So for example, back when the teacher education program was required to have a standardized test as a program entry requirement, one unintended consequence was that students who were afraid to take the standardized test because they thought they would fail, or those who did not have the resources to pay for the tests, simply never applied to the program and were kept out even though they may have very well become well-prepared teachers had they been admitted. So it's important to proactively watch for and investigate these unintended consequences and then act to address them. In the entrance exam example, perhaps the test fee could have been waived for students or covered by the state, or perhaps there could be additional resources and support provided to those who are nervous about passing the test and so on. So thinking through what are those unintended consequences, what are things we can do to address them and make sure the test is actually having the intended consequences. A sixth item in validity is to think about statistical expertise. This has to do with how scores are calculated and the expertise required to evaluate assessments, particularly for high-stakes settings. Most importantly, you should ask for help if you need it. There's many experts in psychometrics in the Education College, and I'm sure many of them would be happy to help support your ability to draw and calculate statistical information from your assessment. In particular, you want to be cautious about drawing inferences that go beyond descriptive statistics, or when doing comparisons between students or between programs, or extrapolating results to other students who didn't take that particular assessment. So if you remember nothing else about validity, remember this. Validity is an argument. It requires providing evidence and an argument for how you're planning on using the results for an assessment. And the bigger the consequences for that use, the stronger the evidence you need to support that use. And, of course, as always, get help if you're not sure. There are lots of people in the college who can help you if you need some support with supporting validity evidence for your assessment. So finally, let's talk about fairness. The standards don't provide a singular definition of fairness, but generally there's an acceptance that fairness is about being free of bias and offering all students a full and equal opportunity to do their best work. So the first issue to think about in fairness is in the assessment process itself. Our goal should be to maximize the opportunity students have to demonstrate their ability on that which the assessment seeks to measure. So for example, if you wanted to assess a student's ability to teach a lesson on the quadratic equation, you wouldn't want to observe them on a day when 50% of the students were out on a class field trip, there was a fire drill, the computer was in the shop for repairs, and the student lost their voice due to laryngitis. That wouldn't be a fair assessment of their true ability. So the assessment process itself should really reflect and give students the chance to demonstrate their full ability on that which you're trying to assess. The second issue in fairness would be access to resources and materials. So fairness is about equitable treatment in the assessment process and thinking about how we make sure that is accessible to all of our students. So for example, if we're assessing students using a video recording of them teaching a lesson, we would want to be sure that all the students had a high quality video recorder that recorded a clear sound. It would be unfair if some students, say, had an IMAX camera, while others had an 8mm black and white video camera. Because clearly those with the better camera would have a better chance at demonstrating what they can do than those who had a grainy black and white kind of bad sound video of their performance. As another example, there was a professional program in an institution where I worked in the past, where the upper class students sold these binders full of their notes, quiz and test examples, and other materials to the underclassmen, and the fee was around $250 each. So those students that couldn't afford to purchase these additional materials were obviously at a serious disadvantage to those who could purchase them. So don't make assumptions about what resources students have available to them. If you are unsure, you can work with the Baker Teacher Leader Center or the ETC or the library to make sure resources are available to students who may need them. A third issue in fairness is reporting scores. It can be easy to violate standards of fairness in score reporting, so be cautious and do not report scores in ways that students can be identified by their classmates. Student ID numbers or even random digits can be figured out, and if you're disaggregating results by demographic characteristics, it can be very easy to figure out who a score belongs to when you start combining multiple demographic characteristics together. A fourth issue in fairness is opportunity to learn. So as you think about predicting student scores on the AP Calc exam, let me ask you just to think about this. What do you think is the biggest predictor of high school students' scores on the AP Calc exam? Okay, I'll tell you what it is. The biggest predictor of AP Calc exam scores is whether or not the student took an AP Calculus course. So in this example, it would be unfair to compare the scores of two students on the AP Calculus test if one of them had taken the AP Calculus course and the other had not, because they had not had equal opportunity to learn the material. So this can be really an important issue in fairness that doesn't always arise as we think about how we use assessments to make decisions about students, is this issue about fairness and opportunity to learn. And finally, an issue in fairness is thinking more broadly about accessibility and universal design. So universal design and assessment is about developing tests that are usable as usable as possible for all test takers in the intended population, regardless of characteristics such as gender, age, language, background, culture, socioeconomic status, or disability. So being proactive and designing tests with this goal in mind, rather than waiting for a student to complain or request a modification to the assessment, is the best practice. So it starts by defining what you want to assess very precisely, avoiding items that bias scores for individuals or subgroups that are specific to those examinees, and maximizing access, for example, by allowing user-selected font sizes, avoiding item contexts that be unfamiliar to those from other cultural backgrounds, minimizing linguistic load when not relevant to the assessment, ensuring assessments are accessible by screen readers and other adaptive devices, and providing accommodations when requested by the Office of Student Disability Services. So that's a quick summary of principles of validity, reliability, and fairness in assessment. It's important for all of the assessments we do, from the smallest quiz to the most important completion exam. However, the amount of evidence and the amount of work we need to put into validating and ensuring reliability of our assessments varies based on the importance of the decision we're making using those scores. Reliability is about consistency. Validity is about making sure the use of the scores reflect things that are supported by evidence. And fairness is about avoiding bias and making sure all students have equal opportunities to achieve their maximum potential. All of these require ongoing attention and are an ongoing process, course to course, semester to semester, throughout a program for a whole student. And I know it can be a lot to soak in and gather up, but feel free to reach out and ask for help. If you need that help, I'm happy to help. I know there are other experts across the college as well if you'd like assistance. It can be difficult to cover all of this on your own, and having an outside eye can often be very helpful. And we do this work because we care about our students and we want to unlock their boundless potential and empower them to become their very best. So thank you for all you do for our students, and please do not hesitate to reach out if we can be of any assistance with your assessments.